We're going to take a look at recursive functions. Recursive functions are functions that call themselves. They can be used instead of iteration, but generally they're less efficient. Now, recursive functions must contain something called a general case and at least one base case. So the purpose of the base case is to ensure that there is a condition for the recursion to stop, because without a base case, if it didn't exist, the recursion would continue to call itself, and then it would be stuck in this series of infinite recursive calls, although in reality the code would just return an error. Now, to look at what this looks like in a general term, so we have a general look at what one of these recursive functions look like. So we have an if-else construct here. So if some condition is met, we return the base case. Otherwise, we are executing the general case where the function calls itself. So the general case is where the function calls itself. The base case is the condition for the recursion to stop. Now we're going to look at an example of a recursive function. The one we're going to look at is the greatest common divisor. So we're going to take two numbers and find the greatest common divisor of those two numbers. This is the function we're going to use. It's a recursive function. It's in fact a tail recursive function, so it has no pending operations that get performed on return from each call. There are different types of recursive functions, but this one here we're going to focus on is a tail recursive function. You can see on line 5 that it calls itself, and then the base case is where it returns the value of x. So let's begin tracing this algorithm. So to begin with, our first call then, call 1, and we're going to keep an eye on the stack frame as well. That's really helpful to us. And we are going to find the greatest common divisor of 8 and 12. Now we should be able to work that out. That's 4, but let's hope that the algorithm does the same thing as well. So we call GCD, which is the name of the function we're using, with 8 and 12, which are the two values we're going to put into that. So the next stage then, we're into the routine, and we get to line 2. Well, y is not equal to 0, so that's false. So then we skip to the else clause and we execute that part of the code, which then means that we need to make a second call to the GCD function, and we're putting the value of y, so putting the value of 12 for x, and we're putting the value of 8 for y there. Now what's basically happened is the two values essentially have flipped around. If we do x mod y, so if x in the previous iteration is 8, we mod 12, well, that gives us a value of 8, remainder of 8, and then the y value in the next call is the x value in the next call was the y value in the previous call. So yeah, we've swapped those values around. So next we're on our second call now, and again y doesn't equal 0, so we execute the else part of the clause, and then again we're making now a third call to our GCD function. Now our value of x is now 8, and our value of y is now 4. X, or 12 mod 8 gives us a remainder of 4. So 8 goes into 12 once, but we have a remainder of 4. So that's why y is 4. So now we're into call 3. Again, y doesn't equal 0. So again, we go into the else clause, and again, we make another call to GCD. Now this time, y is 4, and because 8 mod y is 0, y becomes 0. Now we continue and we make into our fourth call. Now this time y is 0, so that's true. So we execute that block of code now on line 3, which means we return the value of x. Now the value of x is 4, so we return that. So from call 4, we're returning the value of 4. And as we go up through each of the functions, we're now returning the value of 4. So now call 3, so we're in call 3 and we're returning the value of 4 again from call 3. Similarly, call 2, we're returning 4. Call 1, we're returning 4. And then we print that out and it gives us an output of 4. So this has given us what we expected at the start, a value of 4. So that has worked out nicely for us. So that is an example, again, just to reiterate, it's an example of tail recursion. And you can see there that it's been applied to the greatest common divisor algorithm.